Okay, so for problem 6, what's given? Let's just dive in. Read the question, tell me what's given. I'll start composing a list. A, Y, A, X. Oh, I can read it, but I want you guys to read it. Tell me what's given. You are awesome, though. Thank you.
The goalpost is 30 meters away.
30 meters away? I should probably draw a diagram, right? Here. There's the football player. See cute little football player? Here's goalpost. I know how to draw goalpost. See? There's goalpost. And here's football. Do you know why this problem is at the end? Because it's so hard. Do you know why it's so hard? Do you all notice? The object does not land at the same height that it was launched. The physics becomes way more complicated because you have a delta x and a delta y. Okay? So you can see, what's this given in the problem? What's that amount?
30 meters.
Okay, so I'm going to call that my delta x. It's 30 meters. And you guys know a delta y here? That would be this right here, right?
3.3 meters.
3.3 meters. Notice I'm using delta x and delta y. I personally don't like using position so much. It's annoying because you have to define a zero. But if I use displacement, it's just a lot easier for me. I'm just looking at my displacement vector from beginning to end, and I'm drawing my displacement vectors on my diagram. Okay? A displacement vector starts at the beginning where you at and then ends where you at the end. It's your final position vector minus your initial position, and it's a vector. Okay? You just subtract those two vectors. Anyway, what else do we know? We got AX, AY. What's AX? What's AY? Okay, I'll fix it. Sorry, you guys are awesome. What's AY? Okay, we'll use negative 10. And so I'm defining my directions already, so I better be clear on my diagram. This must be positive y, and this is my positive x direction. Are you folks cool with that? You're all good? All right. See if I can erase. There we go. All right. What else? What else can you tell me about the scenario?
35 degrees.
Oh, you got this 35-degree angle, and that's when this thing is launched, right? So homie kicks it, bam. I'm going to draw an initial velocity vector, right? That's my initial velocity. And I'll also draw it like down here. You guys with me? I just copied it down there. Now that initial velocity consists of an initial velocity in the x direction and an initial velocity in the... This is the traditional method of solving the problem. I do have an easier non-traditional method, but I'm not going to show you that now because you're sort of set up to do it this way. All right? And we know this 35-degree angle here. Is that right? They say 35 degrees above horizontal or something like that. You want to be clear on that. Go back and read it and make sure, because any little error, okay, they're not really clear on the question. But it does say angle of 35 degrees, so I'm going to roll with it. That would be the most likely angle they give me. So, cool. Can you tell me which V0y or V0x is sine and which is cosine? So I'm just going to write sine, and you say that's V0y? You're right. I'm identifying the side opposite my angle. This is just how I do it personally. And then I need to multiply by my hypotenuse. So let me give myself a little more room, okay? V0y equals V0 sine 35. You guys dig? And then V0x is so easy. Look, all I do is write the same darn thing, but I replace sine with... So that's the quick, dirty way of doing it, okay? Identify sine first. Whoa, that was nice. What did I write? There's dyslexia. Sorry. Cosine 35 degrees. Are you guys happy? Okay. All right. Well, what do we do now? We got a V0x, V0y that's kind of given. So we'll add that to our givens list. What else we got? So I'll write these really quick. V0 cosine 35 degrees. We got V0 sine 35 degrees. Now, it's not really given because I'm still missing V naught, but at least it's closer. All right? What else? Okay, delta x and delta y. I'll change colors and write those. Delta x equals what?
30 meters.
30 meters, and that's my positive direction, so I'll write positive 30 meters. Delta y equals what?
3.3.
Okay, and that's a positive as well. Very good. All right? 3.3 meters. All right. You want to use equations or graphs or both?
Equation.
Okay. So your V naught in the horizontal, let's start easier. In your horizontal direction, do we have a constant velocity here?
Yes.
So our equation becomes what? Delta x equals, because I've already got my delta x here, I'm going to write it in terms of delta x. Think of the area of your velocity graph.
Time times velocity.
Yeah, vx t. And this is what happens of your position equation if you solve it for displacement and plug in 0 for your acceleration, right? And that's also what happens when you look at the area of your vx versus t graph. Y'all good? So know where this comes from. It's not an equation to memorize. So notice we have how many of these variables? Do we have delta x? Do we have vx? Not really, but kinda. Okay, so we don't have t for sure. So there's like 2 variables in here. We're missing v naught, but at least it's a start. So I'll say we have I'll just write as much as I can. Okay. So we have delta x, we have that, and we got, I'll plug in Vx. Vx is the same as V naught x, right? Because the projectile won't change its horizontal velocity. Is everybody good? So Vx is the same as V naught x, which is going to be V naught cosine 35. So I'm going to write V naught t cosine 35, and I cannot do anything beyond that, right? So I'm going to stop there. Hopefully the vertical direction will be able to help me out a little more. We have a delta y, I see. We have an ay. Any ideas what we could do here?
Set up the equation for changing the position.
Okay, what's that, please?
Delta y
Okay.
equals.
And then I'm going to just add in this. This here is horizontal. I'm just trying to stay super organized and separate the two. Sorry for being that way. I interrupted you. Okay, delta y equals?
1/2 at squared.
Okay.
Plus v naught t.
Do you folks see how this problem is much harder? Now we have a v naught y.
Yeah, v naught yt. And then plus.
Since you wrote delta y, there isn't a third term there. Remember?
Yeah.
Delta y has the y naught and y final in it.
Yeah.
The original equation on your reference sheet is for position y.
Okay, but this is just change.
Yeah. So, yeah, go, brother.
Ayt squared.
Oh, you're a good dude. Thank you. Not like anyone's ever not made that error, huh? That's a common one. Thanks. Okay, so let's just tally what we got. We got delta y. We got ay. We don't have t, right? And we don't have v naught y. Oh, that's too bad. So we have like 2 missing variables. But we have 2 equations and 2 missing variables. Do you guys get the story now? What's going to happen? I think we should take the simpler equation, right? Let's take the equation that says for delta x and solve that for t, right? Now this was v naught x, is that right? Oh no, I messed it up. No, it's not. It's not because I did that here. So we're good. So I'll just take this one and solve for t maybe over here. So what's t equal to? Oh, that's beautiful, huh? Just lost my connection. Huh? Here, I'll pause this. Record again. All right, so t equals, help me please. You should be dividing delta x by a bunch of stuff, right? All right. by V naught T cosine 30, V naught cosine 35. There we go. I think you guys see how this is going to play out, right?
Yeah.
I don't need to solve it further. Where is this T going to go?
Into the other equation.
So it's going to go here and there. It's quite ugly, but obviously if you plug in T there, what's your only variable that's left? Oh, and you're also going to want to plug in this stuff for V not Y. Right there. You guys see that? And if you do that, if you plug that T in for T and the V naught Y for V naught Y, you'll only have one variable, which is V naught. Yeah, you can find the initial velocity that the football was kicked. You already know the angle, so you can essentially find the speed by which the ball was kicked. Yeah, go, Andrew.
But how do you, so the V naught, so the V naught, the two components,
Yeah.
those two components, like when you add them as a vector, that's the entire initial velocity.
Yeah, the V naught is the initial velocity that's in the 35 degree direction above horizontal. But V naught x is only a horizontal component of that velocity.
Okay.
V naught y is only the vertical y component of that velocity. Those two velocities add not as numbers but as vectors to give you your initial velocity.
Okay.
Does that help?
Yeah.
So you got Pythagorean theorem and you got the trig behind right triangles that's very useful.
Yeah.
You'll notice on the back of your reference sheet, they have some convenient angles. I don't see 35 as one of them, so that's not convenient. But I bet the AP College Board gives you one of the angles on the back. I just have a hunch. Does that make sense?
Yeah.
I'll post this and you guys have a great weekend. Are you intending